All right, so you should have had the review test. I posted it up online. I'm going to go the same questions here, so if you didn't print out, it's fine. So there's 7 questions. Points are the same as the breakdown, so it shouldn't be too crazy. It's basically what we were doing before. So I'll be here at 9 on Thursday. So if you want to get here a little early, that's fine. And when you're done, obviously. So all right, so let's look at this. Why do I hear myself? All right, that should be better. All right, so the first question is literally just looking at the normal curve, and we're looking for the z-scores given specific criteria. So the first one says has an area of 0.25 to its left. So when we're looking at this, a little sketch normally helps a little bit here, just to make sure you're getting the right sides. So we're looking at 0.25 to the left, so that's over this side. So let's draw a line, we're looking this way. So that means when we're looking at the z-table, since I have an area and we're looking for the z-score that goes along with that. Z-table. We're basically looking for 0.25 on the z-table. So scroll down. And 0.25 is, we have 0.2514 and 0.25483. The closer one is the 0.2514. So we've got negative 0.6, and then we go up 7. So A would be negative 0.67. So B says an area that's 0.15 to its right. So that's over here. And we're going this way. So what am I looking at on my table for this one? So the 0.15 is what I want, right? Yeah. But the table is going to give me that part, right? So what number am I looking for on my table? So you're going to find that in -1. Right, we're going to subtract. So we're really looking for on the table the 0.85. Okay. Because remember, the table is always giving you from the left to the right. So if I want the other side of it, I have to subtract it from 1 to look at the table. You also could have done the negative version of it and then just changed it to a positive. That would have also worked. But so we're looking for 0.85. So I have 0.8485 and 0.8508. So 0.8508 is closer. So I got 1.04. On that one. All right. The next one on this one is the Z is 0.05. So what's that number represent? That's the key piece on this one, is making sure you understand what that number represents. Is that number to the right or to the left? It's to the right. So this is basically the exact same thing as we just did with B. We're looking for this way, and it's 0.05. So we want, in essence, we're going to do the same thing we just did. We're going to subtract 1. So 1 minus that gives me 0.95 is what I'm looking for on my table. So we go back to the Z table, and we're looking for 0.95. So you'll notice that the 0.95 in this case, we've got two that are right next to each other. So we got 0.9495 and 0.9505. So we get 1.6. So I'll take 4.5 or 1.645. So if you put 1.64, you get it. Put 1.65, you'll get it. If you put 1.645, you'd also get it.
So for C, it says C 0.05. That means go to the right.
That's to the right, yeah.
How do we know if it's left? It's just always right.
That symbol always means, that setup always means to the right.
Okay.
This is the only question on the entire test that the points aren't always exactly the same for, because I ended up getting 99 points at the 0.1 somewhere. So the C1 will be worth the 4 points in this case. So it'll be 3, 3, 4. Just because you have to do a little more work for C. Any questions on this? Okay. Moving on to number 2. All right. So what are the quartiles? If you're going to break something into quartiles, you're breaking it into what? Nope. Well, yes. So 4 parts, right? What's the percentages that go along with those?
25%, 50%, 75%, and 100%.
Well, we won't ever get 100. So the only ones you're looking for is 25%, 50%, and 75%.
I would say, like, if you're like,
Yeah.
then you get 100.
Yeah. So those are the 3 we're looking for. So we want to find, the first thing we have to find for these is we need to find the Z-scores that go along with those, because that's what's going to help me figure out my number that goes along with that. So let's find my Z-scores that go along with those. So we go back to my Z table. Actually, we kind of already did 25, but that's okay. We'll do it again. So 50 is actually easy, right? 50 is 0 is my Z-score. So now it's, because that's right in the middle. Let's find the 25 and the 75. So the 25 was, we did 0.67, right? Is what we just found in the last page. Yeah, the 25 was negative 0.67. So negative 0.67. And 75% we got to find. And we get 0.67. Does that make sense that they would be, because remember, it's symmetric, right? So if I go 25% on one side, it'd have to be the exact same on the other side. So All right, that's not my quartiles. They want the actual values for the scores. So in this case, I've got a mean of 152, and my standard deviation is 8.8. So to find my quartiles, so the 25%, I'm going to multiply the 8.8 times 0.67. So the 8.8 times 0.67. So you get 5.896, and we're going to subtract that from the 152, and we get 146.1. The 50% is just 152. And then the 75% we're going to add. And we get 157.9. Why is it not? Hold on. Why? Sorry, I'm trying to get my the test printed for class on Thursday. There. Sorry about that. All right. Any questions with finding the quartiles? Yes. So remember, the z-score tells you how far, basically tells you how many standard deviations, right? So we're taking this 8.8 and multiplying it by the 0.67. And then we're adding and subtracting it. So subtract to get the 146.1, add it to get the 157.9. No problem. And the nice thing is, remember, it's going to be on either side of it. So you only really have to do that once and then add and subtract it. Okay, you don't have to do it by the times the negative version and the positive version, because those will be the same. The only thing that's changing in this problem is those two numbers. The rest of the problem is basically going to be the same concept for it, because that's how they're set up.
Wait, two decimals for 25% going.
Yeah, how I subtracted it.
Wait, how did you do that again? I was trying.
I did the 8.8 times the 0.67.
Yeah.
And then I subtracted it.
Okay.
That gives you the 25, and if you add it, you get the 75. All right. Any other questions on how I got A? Yes, no?
Well, because like when I multiply them, I get 58.96, and I just subtracted that by the 2.
You're off by a decimal. Did you do 0.67 or did you do 6.7? 0.67. Yeah, I was look, literally you had the exact number. You were off by one decimal place. That's all right. let's do B. So now we're looking for the 99th percentile. So it's actually the exact same thing as the quartiles. You have to find your z-score that goes with it and then multiply. So 99th, if we look at our z-table, we're looking for 0.99. And you get 2.33.
Z-score to the left of the 90th percentile or to the right?
So we're looking for the 99th percentile. So we go to our z-table and we're looking for 0.99.
So it's basically the Z-score that'll come to the left side of
Yes.
0.99.
Yes. You're looking for, so when it's looking for 99th percentile, you're looking for what score you'd get to beat 99% of everybody else that took it. So in this case, the 2.33 is 0.9901, which is the closest one. So that's why I'd use that one.
Yep, I saw that.
So now we're going to do the exact same thing I just did for A. We're going to take the 2.33 times the 8.8. Which gives you 20.50. And then we add the 152. So we get 172.5.
Did you say 8.88?
8.8. No, it says 8.8.
No, I'm saying you said 8.88 instead of 8.
I might have.
Yeah, you did.
Okay. The
That
number,
works.
it's written in the problem. It's 8.8.
Yeah. I was a little confused. I accidentally wrote 8.88.
Gotcha.
So it just messed up my calculations a little bit.
That's possible.
Yeah.
All right. Any questions on that one? Before I move on to C, D, and E, which honestly actually are the easiest of the three. Yes.
We're allowed to use our phones for the Z table for the quiz.
I'll actually have them printed out for you.
Right, so-
Yeah, I'll have them printed out. All right. So 68, 95, 99.7, that's one standard deviation, two standard deviations, and three standard deviations. So this one, you don't actually have to do any calculations. Well, you have to do a small calculation for it, but you don't even have to use your Z table for this one. You're just going to add and subtract the 8.8. So we do 152 plus 8.8, and that gives me the 160.8. Honestly, what I would do is I would literally just keep doing the plus 8.8 and then just go down this list. So 169.6 and then add 8.8 again and get the 178.4. I would do one side and then do the other one. And then just do 152 minus 8.8. And that's the 143.2 and minus 8.8 again. And 134.4 and then minus it one more time. That's 125.6. That's how I would do that one. You could do each one individually. It's fine. Save you less buttons you have to click in your calculator. Any other questions on that one? All right. Awesome. All right. So the next one, we're looking for, this is that binomial expansion type problems that we were doing. So we need the formulas for those. Pulling up right now. All right. So remember, this was the procedure for it. So first we have to find the number of trials. As long as they're greater than 5, which in this case they are, we can do this. And then those are the two formulas you need, the mean and then the standard deviation. So the first thing we have to do for this problem is find my mean and my standard deviation. So my mean, in this case, we have 1,500 times 0.90%. Because we looked at 1,500 cases and it was 90% effective. So which is 1,350. Standard deviation, square root of 1,500 times 0.9 times 0.1, because it's the opposite. And we get 3.49. All right, now that we got those two, we can start doing our calculations for it. So A says exactly 1,325 cases. So remember, we can't figure out exact in this one. We have to do the plus the half. Remember? So we're looking for 1324.5 to 1325.5. So I need to find my z-score for each of those. So remember, your z-score is x minus the mean over the standard deviation. So in this case, it's 1324.5 minus 1350 divided by 3.49. And I really should have picked my numbers better for this one, because we get negative 7.30, which is in essence 0. Because pretty much, if you look at your z table, it doesn't go down below negative 3.5 normally. Anything below that, you can basically consider zero. So in this case, A would be 0. I'm going to come up with 2 different numbers for the other problems in this one. I know the ones on the test actually works. All right, so we're going to actually do, instead of, so we're going to change B to, let's do 13, at least 1,360 cases. Yes,
So why don't you have to find the Z-score?
you can't. What do you mean? Have find no the other one because it's going to be basically be the same thing as that. It was so close. Like it. That's the thing when you're looking at these. The z-scores for both of them are going to be very close to each other because you're only moving by a half. So the reason you need to find 2 is because you go to the table, you have to subtract 2 to find the value. If you find just 1, you don't get the actual value for that specific amount. You're going to get it to the left or to the right of that. So in this case, the other one is probably going to be like negative 7.29, which also is 0. So we're going to bring 0 minus 0, which doesn't really help me. I'll show you the same concept when we do C. We're going to look for the 2 and subtract them. No problem. All right. So this one says at least 1360. So that means we're going which direction? Are we going below 1360 or above 1360? Above. So I want to do, when I'm looking for my number, I'm going to do 1359.5 and up. So my Z is going to be 1359.5 minus 1350 divided by 3.49. And this should give me a Z-score that I can look at. Yeah. So my Z-score for this one is 2.72. So we go to the Z table, and we're looking for 2.72, which is 0.9967. Now, is that the number I'm looking for, or do I have to do something with that? I wanted greater than that number, right? So I have to take it away from 1. So I have to do 1 minus that. Or 1 minus that equals 0.0036. And that's the number. So out of 1,500 cases, the probability that 1,360, at least 1,360 cases would be cured is 0.0036. I'm gonna actually skip C. We're gonna do a different number for A. Because C is the same thing, you're just gonna subtract the two numbers, and I think A is the one that's a little more confusing. So we're gonna do 1347. So if we want exactly 1,347 cases, I have to do 1346.5 and 1347.5. So again, I do the 1346.5 minus 1350 divided by the 3.49.
Wait, why did you cross off 1325 cases in part A?
Because it gave me 0. And I wanted to do an example that doesn't give us 0.
Oh.
So people can understand how to do it. Because the one in the test will not give you 0. So we do this when we get negative 1.00, which I can now look at the Z table to find. And we do 1347.5, 50 divided by the 3.49. And we get negative 0.72. So now we can go to our Z table. And we're looking for negative 1 and negative 0.72. So negative 1 is 1587. Is 0.1587. And negative 0.72 is 0.3 or 2358. So now to find exactly 1,346 cases or 47 cases, I would subtract those two numbers. So I do 0.2358 minus 0.1587. And I get 0.0771. So approximately 7.71%. So for the chance that it'd be effective in exactly 1,347 cases, it's 7.71%.
So when we're doing C, you do the same thing, subtract?
Yeah,
Okay.
you're gonna get that's what I'm saying. So in essence, A and C are very similar. C just gives you the two numbers, so you're gonna find each one and subtract them. It doesn't matter. Yeah, it doesn't matter. You could have left it as the 0.07171. Because it just says find the probability, so each of those will be fine. All right. Next one. The Western pygmy possum. The weights of an adult pygmy possum in Australia are normally distributed with a mean of 8.3 and a standard deviation of 0.4. We want to find the standard deviation for a sample size of 16. And then we want to find the percentage of samples of 16 that are between that mean weight within 0.125 grams of the mean weight. And then we want to find the percent samples of 25 of them that have mean weights between those. So how do I find the, remember, when we're looking at doing the mean stays basically the same. The standard deviation changes. What was the formula for the standard deviation?
Over the square root of n.
Yes, and that's my sample size. So for A, all it's looking for is that. So the standard deviation of the sample is 0.4 divided by the square root of 16. So that's 0.1. Any questions on that part? Okay. So B, we're actually going to use that. So we want the mean weights within 0.125 grams of the mean. So that means if we're thinking the mean, if we're going to 0, right, it's 0.125 to the left, 0.125 to the right. So I'm just going to take the 0.125 and divide it by the 0.1, and that's going to give me how many standard deviations on either side. And that's 1.25. And since I want both sides, it's plus or minus that. So I have to do it both directions. So if we look at my Z table, we're going to look for negative 1.25. You get 0.1056. And then if we do the positive one, .8944. And since I want between those two, I'm going to subtract. So for B, it's 0.7888. And actually, this one asks for a percentage, so it's 78.88%. So 78.88% of my samples will have a mean within 0.125 of the actual population mean. What's the only thing that changes for the next problem for C? Sample size. So what is that? That changes my standard deviation a little bit, right? So in essence, we're going to do the exact same thing. We're just changing, instead of doing it out of 16, I'm doing it out of 25. So 0.4 divided by the square root of 25 is 0.08. And now we're going to do the exact same thing. I do the 0.125, but this time I'm dividing it by the 0.08. And I get 1.56. So, 1.6. And remember, same thing. We're still looking at the positive and the negative version of it. And then we subtract those two. And we get 88.12%. And you should get a higher percentage. The bigger the sample, again, remember, the more sample, the tighter it gets, right? So I should have a higher percentage of them. Any questions on that one? All right. A roof manufacturer claims that his material will last an average of 25 years. Assuming that roof life is normally distributed and it has a standard deviation of 3 years, answer the following questions. Suppose you put a roof on one house and it lasts 23 years. Would you consider that evidence against the manufacturer's claim? So is what they're saying wrong? To show this, we need to figure out the Z-score. We have to figure out how unusual is this occurrence. Okay? So if we take the 3 years, so we do 20, we basically have to find my Z-score. So we're going to take 23 minus 25 divided by the 3 years. So negative 2 over 3 is negative 0.67.
Thank you.
Okay?
Thank you.
So now if we look at negative 0.67 on our Z table, 1, 2, 3, 4. We get 0.2514. So there's at least, it's 25%, 0.14 is less than that, right? So if he says his roof is going to last has an average life of 25 years, and you got 23 years out of it, would you say he was wrong? 25% means 1 in 4 roofs are going to be lower than that, right? So that's not that bad. He's not guaranteeing 25 years exact. He's saying an average of 25 years. So that's within the realm.
So it's not evidence against manufacturer's claim?
No, because that number is close. Like, it's not a very small percentage. Remember, where do we start thinking about on the bell curve being unusual? That's like anything after 3 standard deviations is out of the realm. Okay, when you start getting close to that, you can start to get a little bit, but this is within 1 standard deviation of it. So that's, you wouldn't complain if your roof lasted 27 years, which is the exact same, just the other direction. All right, let's look at B. So now we have 100 houses. So now we've got a sample size, right? So now we have to figure out what my Z-score is, or not my Z-score. We have to figure out my standard deviation. So we're going to figure out my standard deviation of this one. We have to take the standard deviation originally, which was 3, and divide it by the square root of 100. So I get 0.3 is my new standard deviation. Suppose you put your roof on 100 houses and it lasts an average of 24 years for those 100 houses. Would you consider that evidence against the claim? So now let's look. So my new Z-score, I'm doing 24 minus 25, and I'm dividing by 0.3. and I get negative 3.33. So you actually don't necessarily need to find your percentages to make your claim, because you're going to use the z-score, you're going to use the standard deviation, how far away is your z-score anyway. In this case, it's negative 3.33 standard deviations away from the mean. Is that normal? No. Remember, we make doors based on 3 standard deviations. So if this is negative 3.33 standard deviations, it's more than 3 standard deviations away from the mean. That is unusual. So I would say that their claim is wrong, because it's more than 3 standard deviations away from the mean.
Thank you.
Okay. Yeah, I'm actually going to do 7 first, because 5 and 7 are very similar to each other. So I'm going to do this one first. So water softener salt comes in packages marked a net weight of 40 pounds. The company's package claims that salt claims that the bag contains an average of 40 pounds and the standard deviation of the weights is 1.5 pounds. Obtain the probability of weights of one randomly selected bag of salt will be 41 pounds or less. So A is quite simple. And A and C go together, and then B and D go together. So A is finding the value, and then C is actually saying, is the claim true or not? So we've got one bag, so it's just a normal straight standard deviation. So I've got 41 minus 40 divided by 1.5. So I got the 0.67. Now, it wants the probability that the weight is that or less, which means to the right, so that's a good thing. So I just got to actually pull up the z-table and find my 0.67. So 0.67, and it's 0.786. Sorry, that was off. 0.7486. Yes. So 74.86% of their bags will have 41 pounds or less. So do you think that means their claim is wrong? That the net weight's 40 pounds? No, that's the 0.67 standard deviations well within the range there. All right, and then so that's basically A and C. So if we do the same thing for B, now we're looking at 10 randomly selected bags, so I got to find my standard deviation for this one. Slide. So my standard deviation, I have to do the 1.5 divided by the square root of 10. And I get 0.47. Now we got to find my z-score. So we're going to do 41 minus 40 divided by 0.47. And I get 2.13. So the percentage now 2.13 is 98.34. So we got 98.34% of the bags are less than, are 41 pounds or less. So 2.13, is that enough to not claim it?
Yeah.
Actually, it'd be
It's within 3 standard
it's
deviations.
still within 3 standard deviations. So if we're using 3 standard deviations as our benchmark right now, the claims are still probably true. It's not to that 3 standard deviation mark yet.
So for B, you're saying the company's claim is somewhat true, or is it not entirely true? I'm confused.
So
How do you go
no,
about that?
the answer to B is 98.34%.
Yeah, it's
The answer to D is it's not, we're using 3 standard deviations as our benchmark right now. So if it's outside of 3 standard deviations away, the claim is false.
but the Z-score was 2.13.
Is that within 3 standard deviations?
Yes, so
Then it's, the claim is true still. We're not saying the claim is incorrect. The next section that we're going into, we're going to start to formalize that concept and be able to figure out exactly if its claim is true or not. And it's going to be based on what percentages and stuff like that we're going to use. Right now, you're using 3 standard deviations as your benchmark. As long as it's within 3 standard deviations, we're good. Okay? All right. In the 1950s, the mean height of women in their 20s was 62.6 inches tall. Assuming the heights of today's women in the 20s are approximately normally distributed, with a standard deviation of 2.88. If the mean height today is the same as that of the 1950s, what percentage of all samples of 50 of today's women in their 20s have a mean height of at least 64.24 inches? Okay. Really complicated way to say exactly what we were just doing. All right. We're looking at what's the mean. We'll start that because 2 things we need: mean and standard deviation. What's the mean? 62.6. This is my sample. That's my sample mean. So 62.6 is my mean. My original standard deviation was 2.88, correct? Okay. So what's my sample standard deviation? I have to do 2.88 divided by the what? Square root of what? What's my sample size?
square root of 50.
Samples of 50. So we get 0.41. So now I can go through and do find my z-score. 64.24 minus 62.6 divided by 0.41. And we get 4. So what percentage of samples of 50 women today in their 20s have a mean height of at least 64.24? None. Because if we look at, or you can technically, I guess, do 0.000001 or whatever, but basically, if it's over the 3.5, it's outside of that range. Not that this question asks this, but what do you think that means? What's the average height of a woman today? Right around 5'4", actually, which is 64 inches, right? This shows that the mean height has changed since the 1950s. We've gotten taller. That's what that shows. Okay, that was the entire, it wasn't asking that, but that's in essence what that was showing. Same thing as the other one. It's testing a claim. Okay, so it's using what we got to test claims. Okay, so in this case, no one should have that. No one should be in that situation. We know that's not true for today, but that's based on this question. Okay, there's your test.
Pretty much, that have no card.
Yes, always allowed to have a no card.